The magnometer readings indicated that the ocean floor is not the stable structure, but rather it is continually formed at mid-ocean ridges. For example, the mid-Atlantic ridge then apparently is where the floor of the Atlantic Ocean was formed. It seems the continents once formed a supercontinent called Pangaea, which then split starting in the early Jurassic in the North Atlantic and then continuing into the South Atlantic by the Cretaceous period. So the continents were pushed apart as the mid-Atlantic ridge formed new sea floor from the magma which welled up from the mantle. These readings have been confirmed with age calculations of various points on the ocean floor and are consistent with the sediment buildup over the ocean floor, which is thinnest at the mid-ocean ridges and thickest near the continents. It appears that the mid-ocean ridges are the sources of the magma, which then solidifies and forms new ocean crust. Over time, and in this animation, the older crust is depicted by the darker shade of red, the addition of new ocean crust forces the continents farther apart and the ocean grows. Ocean crust is not permanent, and at some point this denser crust then is subducted under the lighter continental crust. Once this is directed towards the mantle, it will then become magma once again and can be recycled, eventually forming new ocean crust. Thus, throughout the oceans of the world, the youngest crust, which dates to the Pleistocene to Pliocene epochs from 0 to 5 million years ago, this ocean crust would be found along the mid-ocean ridges. Slightly older ocean crust from the Miocene, from 5 to 23 million years ago, would be found next to the red band from the Pleistocene to the Pliocene. Older still would be Oligocene crust, which would then be found further from the mid-ocean ridges. Eocene crust in pink would be older still and farther from the mid-ocean ridges. Paleocene crust would be older still. Crust from the Cretaceous period, which was longer, 65 to 145 million years ago, would be older and thus farther from the mid-ocean ridges. And then finally, there is not much Jurassic crust on the ocean floor left, only two patches, the largest patch south of Japan and another patch off the east coast of the United States. This dates up to 160 million years of age, the oldest crust on Earth. Thus, the oceanic floor is much younger than the continents. Some continental rocks date in the billions of years of age.